Here is video number 3 on Unit 3, and we're actually getting into the section now. The section number, oopsies, refers to the textbook. So it's a little weird. We're in Unit 3, but it's section 2.1 in the chapter because the first section in this year in math is basically just the review. So Unit 1 was all review, so your units and your textbook chapters aren't going to match. Oh well. All right, so we are going to talk about some more angles. And this is stuff maybe you took in grade 10. Yeah, maybe not. But vertical angles are actually really easy. Yeah, so vertical angles are across from one another when two straight lines cross. And they always come in pair. So angle 1 and angle 3, either across from each other. They are vertical angles. And angle 2 and angle 4 are a pair of vertical angles. The nice thing about vertical angles, oh, it's already down here, which is the other thing you want to highlight. They're always equal. As long as you have two straight lines that are crossing, you are going to have vertical angles that are equal, and they are, okay, I'm repeating myself, across from one another. Now, name the pairs of vertical angles in this diagram. I could be lazy and go 1, 2, 3, 4, number them off, but good practice. Let's do it using the name. So I'm going to do this angle first. So angle, now I'm going to start at one end, go to the middle, and go to the other side. So A, E is in the middle, D is on the other side, and then I'm going to do this one is equal to angle CED. You can do BEC, it doesn't matter. There's not any real rules on which way to have to do that. Okay, and you can see by looking at those are the two big angles. Now I'm going to do this one, my smaller one, angle AEC is equal to, okay, I also have other people around. This is what happens when you make math videos at home during the summer. You see your people. And this one over here is DEB. Oops. I guess I could have left it. I could have put BED. Or I said depth first. So remember, you can flip those. What's key when I'm looking at these is it needs to make sure that the E is in the center. Because if you start talking about angle, let's say ACE, that doesn't exist in this diagram because you can't go A to C to E. You always got to go in order. So this, wrong, does not exist. All right, so with vertical angles and your knowledge of supplementary angles from the previous video, you can start calculating some cool stuff. All right, so in our picture here, see, I keep stealing this stuff off the internet, and it's nice and labeled, not having to use those big, long, three-letter things. I'm just too lazy. All right, so angle Y is, oh, look, those are vertical angles, right? They're across from one another. 76. Whoops. Vertical angles. Where was I going with that? Ta-da, they're vertical angles. They're going to be the same size. Nice and easy. Now, angle X. Well, angle X isn't a vertical angle, but if we look at it, that is a handy dandy straight line, which we all know is 180 degrees. So if I go 180 degrees minus 76, ooh, math is too hard today. 180 minus 76 is 104. Oh, my bad, forgot the degrees. Because they are supplemental. You could also say form a straight line. Those two answers are probably going to be the same for everybody. But when we get to angle Z, Well, okay, first of all, angle Z is going to be 104 degrees. Oops, 104. I'm just going to round. I hate doing math in pen, but if I use pencil, you guys can't see it very well. So it's 104. The Y is going to depend on, simply there's two answers. You can either say it is vertical to, what is vertical to? Vertical to angle X, so it's going to be equal. Or you can say it's supplemental. Oh, what a mess. To angle, let's see, Z is supplemental to angle Y. So that makes it easier for you because there is more than one answer. Makes it also a bit of a pain for me, but it's okay. Either one of those is completely right. And actually, I'm even going to make this better. I'm going to go up here to Y. Supplemental, no, never mind. I was going to say to the 76-degree angle, but that's obvious. So we're good. Awesome. And here, ta-da, we have another one of those fun mathy things we can do with an equation. Now it says find X and the measure of all the angles in the diagram. Okay, I'm actually thinking I did not leave us enough space to do this, but let's make it happen. What is the relationship between these two angles? Well, it should be obvious because, we've really only done one thing, which is vertical angles. So we know they're equal. So we know that X plus 16 is equal to 4X minus 5. Whatever those angles are, I don't know, but they are equal. So let's solve this equation. Let's subtract X. So 16 is equal to 3X minus 5. And then we can add 5 to both sides. So 3X is equal to 21. And divide by 3, divide by 3. And we get 7 is equal to X. So there's the first part. Always, 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 please read your question, because if you give me that much, you get half marks on the question, maybe, because you did the hard part. But it also says find all the angles in there. So I'm going to do it over here. So this one is going to be 4 times 7 minus 5. Right? I should have rewritten it, but it's right there. So 4 times 7 is 28 minus 5, which gives me 23 degrees. I could at this point then say, well, hey, this one over here is a vertical angle that's going to be the same, and it's going to be 23. Yeah, I could. But I'm a paranoid mathematician, and I would rather double check my work, and I got time. So I'm going to do this one, and I'm going to put in the X is equal to 7. So I'm going to have 7 plus 16. 7 plus 16 is 23 degrees. And by doing that, ta-da, look, same on both sides. So I have now double checked my work, and I know it's right. And then if I want to do this one, well, I know that this angle plus this one, that's going to be supplementary. Anytime that you could draw that half circle, a semicircle, you know those two angles are supplementary. So then I can go 180 degrees minus 23 degrees. And I am lazy today, so it's 157. And I also know the one down here must be 157 too, because it's a vertical angle to that, or I can say this one's 23, so those have to add up to 180, however you want to do it. All right, the last question here. Sets of vertical angles. All right, so I wanted to show you that you could have more than just 2 lines. But it doesn't matter. What you do is you consider 2 lines at a time. So I can look at this one and this one. And this is going to say angle 1 is equal to angle 4. Now, technically, if you take a whole bunch of geometry, that should really be the measure of angle 1 is equal to the measure of angle 4. but that happens if you take University of Geometry or way back in the previous century when I took math at school. There was actually a Geometry 20 and 30 class, which I took. But for what we're doing, angle 1 equals angle 4. All right, now if we take a look at this line and this line, we can see angle 2 is equal to angle 5. And which are the ones we didn't do yet? Angle 3 is equal to angle 6. And basically, that's all there is in this one. Sometimes there's extra sets, but that's it. All right, supplementary angles. Now, here's an example where we have more than one. So angle 1 plus angle 2 plus angle 3 is 180 degrees, right? Because you look, there you've got a delightful semicircle. If I want to do the other half of that circle, I can say angle 6 plus angle 5 plus angle 4 is equal to 180 degrees. That's this one. And then you can just do whichever variations. There's a lot here. We can go 2 and 3 and 4. And then we could do 3, 4, 5 and 4, 5, 6. Oh, I did that one. 5, 6, 1. There's, I don't want to do the combinations, but there's a whole lot more that you can do, because you could even do like 1 and 2 and 5. Whoops, no. 1 and 5 and 3, because these two are the same 5. As long as you give me 3, I will be happy. And that is vertical angles. Remember, this key right here, this is going to save you so much time if you remember that. That vertical angles are always equal. It doesn't matter lines are parallel or not, which is going to come up later. They're always, 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 always equal.